Hi there, still in Geometry, Unit 6, Section 6.2, Properties of Parallelograms. This is video 2 of 4. I'm going to take a moment now to do one of the exercises I kind of really enjoy when we get into quadrilaterals and various types. I like taking figures and marking up what we know. It's a good general check of how well you've been paying attention to all the justifications we've talked about in class. We're going to be pulling things all the way from the first unit, embedding them inside of parallelograms. So I'm going to take a moment on these 3 different parallelograms and just write down knowledge that we know. So let's start with, we know a parallelogram has opposite sides that are parallel. So let's place that on our drawing. We also know that opposite sides are congruent inside of a parallelogram. So we have sides that are congruent. We also know that opposite angles inside of a parallelogram are congruent. So here are opposite angles. That's one pair. Here's the second pair. And then lastly, we also know that consecutive angles are supplementary. So if I call this angle 1 and angle 2, I could say the measure of angle 1 plus the measure of angle 2 equals 180 degrees. All info that we know is true on a parallelogram. So what if we draw in another diagonal? So I could take all that info we just talked about and I could recycle it. So we have opposite sides parallel. We have opposite angles congruent. Opposite sides congruent, sorry. We also have opposite angles congruent. So I'm going to pause right there on the drawing. You should notice that we actually have 2 congruent triangles inside of this drawing. I have a segment here, which is part of the 2 dash congruent segments. I have a segment here, which is the 1 dash congruent segment, and then I have an angle, all of which gets copied down here. Here's one segment, here's the other segment, and here's the angle. So by side, angle, side, these 2 triangles are congruent to each other. Or if you wanted to, you could label this third side being congruent, and you could say through side, 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 the opposite angles are congruent. So you have 2 triangles that are congruent, therefore you can say lots of stuff inside of them is congruent through CPC, TC. Or, another thing to consider, we have opposite sides being parallel. So I have parallel lines being cut by a transversal. Hopefully everybody sees that this angle here and this angle here, they're also congruent. When given parallel lines, alternate interior angles are congruent. And that's not the only set of alternate interior angles inside of this drawing. We have the left and the right side being parallel. If you consider those as the parallel lines being cut by this transversal, now we have another pair of alternate interior angles that are inside of the parallelogram that would also be congruent. Okay, let's explore the last drawing here. We have all sorts of stuff happening with both diagonals drawn inside of this parallelogram. So let's start off with, we know the opposite sides are congruent. We know the opposite angles are congruent. We know the opposite sides are also parallel. So let's jump into some new things that we know. So the diagonals of a parallelogram bisect each other. So that means these smaller pieces here are congruent to each other. And we also know that vertical angles are congruent to each other. So I have this angle right here and this angle right here are congruent through vertical angle theorem. Now hopefully you can see I have a pair of sides, another pair of side, and an included angle is congruent. So this triangle right up here, we'll call this triangle 1 and this triangle 2. These 2 triangles are congruent through side, angle, side. And we could keep going. There's more triangles in here. There's the 2 smaller triangles on the left and the right. We'll call this triangle 3. And we'll call this triangle 4. Hopefully you notice that opposite sides in a parallelogram are congruent. So now on these 2 triangles, this triangle right here and this triangle right here, we have congruent triangles through side, side, side. And keep in mind on this drawing particularly, we could label all sorts of things. We could label both pairs of opposite sides parallel and congruent. We could label the opposite angles being congruent. We could find a bunch of alternate interior angles, label them congruent. we could spend a good deal of time on that parallelogram and not run out of things to say that are congruent. So just take note that on a parallelogram, we know a lot of things are true. The properties are true, the 4 new properties, as well as anything that we can apply with parallel lines or vertical angles or any other justification that we've learned in the past.